My name is Jordan Little, and like Bill said, I am with Pathion. And Pathion is a vertically integrated energy company. And so we're not just attacking energy storage or just batteries or just components or just full-scale solutions. We're actually hitting from the mining to the battery cells to the actual patents surrounding various battery chemistries to full-scale solutions that are available and ready to go today. So Pathion is actually divided up into 4 different divisions. The one that we're going to focus today on is actually Pathion Power. So we're going to be talking about energy storage and resiliency through energy storage. But just to briefly touch on some of our other corporate divisions, we have Pathion Materials. So that's where we have certain patents around various chemistries that are very high power and are very safe. In addition, we have Pathion Marine, where we have hybrid electric boats that are fully Coast Guard approved and actually in operation today. We also have Pathion Extreme, which is a fuel cell based division for keeping soldiers safe in the field, as well as ensuring personal power. So just to touch on resiliency, a lot of terms come to mind when you think of resiliency, but this actually comes directly from the DoD's directive that was released on climate change at the end of January this year. And so it's about being able to adapt to conditions that may or may not change, that are unpredictable, to respond to and recover rapidly from disruptions. So when we're talking about energy and being resilient, it's not necessarily just about maintaining 100% uptime, and it's not just about having a backup generator if you already are plugged into the grid. What it's about is having continuous operational continuity and excuse me, becoming self-reliant behind the fence. So if you're talking about CONUS, you're not going to be relying on Georgia Power or TVA for your power source. As a military base or as an armory, you cannot control what's going to be happening to the grid outside of your fence, but you can control what's happening behind the fence. So it's about moving the generation and the supply behind those fence lines, because vulnerabilities happen when we have to rely on a third party for our energy or for our reliability. So the actual value of the resiliency is currently a topic still being negotiated today at the Pentagon. But basically, resiliency can be best achieved through complete, total, turnkey packages, not just through one piece of a puzzle or one battery or one specific solar technology or wind. It's about the total package and how it functions within the unit. And so within CONUS, grid interruptions are still a problem. Maintaining 100% uptime for communications is key to national security and international security. So it's not so much about what's our price per kilowatt hour that we're getting from the utility, but it's about assessing the risks of losing that power or assessing the risks of that value changing of how much you're having to pay for electricity. So when we're talking about for the global force, so actual expeditionary installations, typically it's dedicated generators at one base. And these generators typically do not communicate with each other. So if one part of the base is not needing as much power as another part, we cannot scale up or ramp down the generators to meet the load. We actually have to run all the generators at a base load even if the power is not being used. So it's actually a very wasteful use of resources of fuel. So in order to make that better, we either need to make the communications better between these generators or replace them with something else. And one option is replacing those with an actual energy storage system. Energy storage systems, in comparison to just typical backup generators, are going to be much more reliable, a lot easier to maintain because you can actually have scheduled maintenance instead of unpredictable maintenance. They can actually be smart, so they can actually adapt to what the load is doing, and they're going to provide a lifetime of benefit instead of being decommissioned after 2 or so years. So we at Pathion have created a division called Pathion Power, where we're actually offering full total solution packages for energy operating systems. And we can get at least 10 years of operating life without ever having to replace a single cell in the system. We have one of the most highly efficient systems, and we're talking about from whether it's a PV source, a micro turbine, doesn't matter what the input is, we're going to get over 88% round trip efficiency. Most people cannot claim above 80%. Also, our system can act like a living organism. It's going to actually reroute around failed cells or failed parts of the system, so you're always going to have 100% uptime. And whenever there is a failure, it's actually going to give you an alert before it even happens. It can predict where something is going to fail, or it can predict where you can get a little boost of efficiency with a simple procedure. So today we currently have products available today. It can either be for buildings, they can be containerized solutions that can be installed outdoors. They can actually all be connected to create one ecosystem of multiple distributed energy storage systems. Can all have a central controller where we can actually meet the demand for the load with our distributed energy storage systems. So like I said, with resiliency, the solution is not just found in a battery, it's found in that total package. So what we've done is actually create that total package. We have the battery cells, we have the battery management system, we have all the software, all the hardware that's required to get these things running 100% in the field and be very, very reliable. So one way that we've been able to achieve this is through what we call the energy operating system. So traditional energy storage is kind of like a dumb phone, where it has very basic applications to make and receive calls. We've actually created an operating system that has a base platform that you can tack on various different functions. So the same system can adapt to any changes it may see within the next 20 years, just like updating your iOS. So you can kind of think of the operating system as having two primary functions. One is actually controlling the batteries and making them to be as reliable as possible. The other function is the actual functions. What can the energy storage do for the base or do for the load? So you can think about it as controlling your costs of your energy and your energy storage, as well as achieving the operational resiliency. And so just a couple of things that we can do within the operating system can enable from behind the fence a way to actually generate revenue, to decrease demand charges, to shave off peaks, to provide black start, to provide ramping support. There are various grid activities you can participate in to keep your grid as reliable as possible, also while reducing your costs. And one of the most important things with any kind of battery, any kind of energy storage technology is safety. The way our system is designed, it's actually modular. We can actually take a single cell and send that up to thermal runaway. So that's 300 degrees Celsius plus, very, very hot. And that heat will not propagate to any of the surrounding cells. So if there ever is a problem or if there ever is a failure, it's not going to be catastrophic. It's going to be isolated to a very small section of the system. And if that does happen, the system can switch from series to parallel in real time and route around that failed area. So here's a little short video of our serviceability. One of the cost control and the cost saving measures that we have implemented is being able to get down to the cell level for service. So any high school student can go out and actually provide a service event or a maintenance call on our system. You don't have to be an engineer, you don't have to have any special training. It is literally just a cover you remove, a cell you take out, and a new cell you put in. And it'll tell you exactly where that cell is located if there is ever a failure. So there's no guesswork, there's no special tools, there's no special training, making the system to be as reliable as possible for as long as possible. Very, very simple. So there's a couple of different ESS companies out there I'm sure you've heard of, maybe like Tesla or Greensmith or Samsung, LG. Kind of how we're different is that energy operating system. We're going to be able to actually balance every single cell individually. We aren't going to treat the batteries like a dumb block of bricks. We're going to actually treat every single cell individually to make them produce as much energy and hold as much energy for as long as possible. We can scale, we can change in the future, say in 10 years, new battery technology is coming out. And new battery technology is coming out every month, you read about it. So if there's a bigger, better battery, we can actually just switch out some of the system with these better batteries. to make it as profitable as possible for that initial investment. And one of the biggest things are those applications, those functions that we can add to our system. Because we have that operating system, we can change with whatever the load needs. We can add new applications, come out with new ways to manage energy to be as profitable and as valuable to the base, the armory, the load, whatever it is. So, in summary, resilience is a national security issue. This is at CONUS. This is not just expeditionary. This is at home. And we want to be able to provide systems that are going to provide that reliable power no matter what's going to happen. So we have the full-scale systems ready to go today, and they're actually in the field right now operating very well. So that's it, and if anybody has any questions or wants to chat, can do.
So you're not going to get up that easy. Yeah, at least get one question.
All right.
I imagine your system, your management system, is technology agnostic.
Exactly.
From the technology and storage. But every time we talk storage, and I know storage is it's kind of like a foreign term, especially for the tactical army. I think the strategic army is starting to figure it out. But let me ask you a question: Are we going to get past batteries and other novel storage capabilities that maybe are inherently less riskier, or I don't know, or are they mature enough?
Right. Today, batteries are mature enough, and it's about how you're going to manage that and how you're going to integrate multiple pieces of technology. So having a risky or a volatile chemistry is not going to be the best thing to be deployed in the field. Something that's stable, lithium iron phosphate is kind of the standard right now for the military. It's been proven time and time again that it's a very stable battery. But from our perspective of being agnostic, we are looking at treating the whole system and not just the battery. For our first priority is making sure the battery is very safe, and our second priority is integrating every single part to work together. So I think in deployed situations, it's about that management. I mean, even with generators today, if there's just a better management system for distributed actual diesel power generators, that would cut fuel costs in half. So.
Now, do you have actual practical implementation anywhere?
Right. One of our biggest customers is actually Johnson Controls. Our system is part of their product line. Those are deployed in the field today.
Okay.
Cool. Thank you.
Thank you, Jordan.